Hi, I'm Mike Lally, president of the Modal Shop, and today we're interviewing Mr. Marco Perez, who is the Modal Shop Structural Test Product Manager. Hello, Marco. Thanks for joining us today.
Hey, Mike. How's it going?
Good, good. What we want to do today is a quick discussion to help our community understand a little bit more about TEDS and the State of the Union with what's going on in TEDS. So just a really quick overview for the customers who might not be familiar with TEDS. What is TEDS?
Well, TEDS it's a technology that enable sensors, transducers, to have their calibration information built into a little piece of memory embedded into the sensor. So TEDS stands for Transducer Electronic Data Sheet, and essentially we are storing inside the sensor this little piece of tiny memory. We are storing all the information relevant to that sensor, such as the sensor model number, the manufacturer, the serial number, the calibration sensitivity, and other information that relates to that particular sensor specification.
Okay, so kind of what's the genesis? Why does TEDS exist? Where did it come from?
That came from a desire of the sensor industry to move the sensors one step up. You know, when you connect a sensor to a data acquisition system, you know, the sensor is a transducer. It transforms a mechanical measurement, a mechanical like a vibration or sound, into an electric signal. And that electric signal, you know, how do you give meaning? How do you provide meaning to that voltage signal you're getting? That you do that through the calibration. And by enabling the sensor to have the calibration information inside of it, you know, you guarantee that what you're measuring translates into the real thing you're measuring. And you avoid errors such as entering the wrong calibration value into the data acquisition setup. You know, you avoid things like mixing cables and mixing sensors. So essentially, you know, if you have one sensor, it may be easy, but there are a lot of situations where you have dozens of sensors or hundreds of sensors. And to keep track of each one of them can be a very big task. And by using TEDS, you make that automatic. You make that more human error proof.
So it sounds like you're saying we're not only helping to ensure the accuracy of the scaling of the measurement,
right,
but we're also making it easier to do the bookkeeping and
the
to take
bookkeeping,
care.
exactly.
So how is TEDS implemented in an ICP sensor? How is this made easy?
Well, an ICP sensor is little tiny like this one. So I brought a big one here. And essentially on an ICP sensor, you have the electronics integrated into the sensor. So in the case of an accelerometer, I have a charge preamplifier inside the sensor. And what we've done, we added a memory chip to that existing electronics. So that memory chip stores the TEDS information. And with ICP technology, the same two-wire, the coaxial wire that we use, can also be used to inquiry the TEDS memory. So basically that sensor functions into two modes: a analog mode, which I'm measuring the signal of the sensor itself, but I can also change that sensor into a digital mode, where essentially what I'm doing, I'm downloading that data, that specification data, that calibration data from the sensor, using the same two wires that all ICP sensors use.
Okay. This sounds like a very nice digital extension of the ICP analog technology that PCB Piezotronics was one of the pioneers of.
And it also guarantees, you know, backward capability.
Sure.
So a TEDS sensor it's still 100% compatible with all the existing equipment out there.
Understand. So in analog mode, it works the same way.
In
it
analog
always
mode,
did.
it works the same way.
Okay. Well, that kind of leads us to say if analog mode is the way it always worked, and now there's this TEDS opportunity, a lot of our community is interested in what is the state of the union? Where are we with TEDS? What's new and what's mainstream now?
Well, nowadays, the TEDS, it's more and more a technology that's being adopted across the board. It started with the transducer manufacturers, and now it's being embraced through more and more transducer manufacturers as well as the data acquisition manufacturers. Because I mean, TEDS is something that, just the sensor by itself doesn't do any good. You have to be able to read that information to your data acquisition. So more and more, if you just look at, for example, the IEEE website and the list of manufacturers nowadays that are listed in there. When we started 10 years ago, it was like half a dozen sensor companies. Now we have like hundreds of companies there that are embracing the technology and supporting the technology into their equipment. So it's pretty much like in the PC world. When USB came up, USB was a technology that enabled plug and play. Nowadays, everybody takes it for granted. You plug your digital camera, you plug your iPod into your computer, the computer recognizes, okay, oh, this is a camera, this is a media player. With TEDS, it's the same thing. You plug your microphone to your data acquisition system. Oh, this is a microphone. Oh, this is an accelerometer. This is a load cell.
So what is the rest of the industry doing? It sounds like this is expanding to plug and play
Right.
through adoption. Give me a little bit of understanding what's going on through the industry.
So through the industry, what's going on is you have more and more sensor manufacturers, including the TEDS feature into their sensors. So when you design a new sensor, you have the option to include the TEDS capability or not. So more and more sensor manufacturers are adding that as a feature to their sensors. And more data acquisition manufacturers are doing the same thing on the other end, by enabling and supporting that technology. And that's only possible because TEDS is a standard. It's a standard that was written and published through the IEEE organization. So it's very well defined and was signed up and defined, published in 2004. And right now, 2011, we had enough time where people digested and they implemented that into their equipment.
So where do you see things heading? Is there a direction that's clear for the future?
Well, I think that there's a clear direction that, TEDS is a very useful feature. It makes it very convenient, it makes it easy, it makes it plug and play. And as companies approach and try to make their equipment easier to use and more error-proof and so on, I would expect this to be adopted more and more across the board. So the TEDS technology was led by the sound and vibration industry, but nowadays you see, for example, the load cell industry, adding TEDS across the board, and we're going to see TEDS into other types of sensors that we haven't ever thought about.
So with this amount of time and version, well, frankly, the amount of time and the amount of sensor types that are coming in, is there any challenges with either templates or version compatibility, things like that?
Yes, there is. I mean, you always have to make sure that the sensor and the equipment that you're going to use talk to each other. So essentially, if they follow the standard, they will talk to each other. But what happens is, there were some sensors that were made in the very beginning, and they follow what we call the preliminary templates. And there were a lot of equipment that was designed to support those templates. And that's what some people call it the version 0.9. That was like the beta version of TEDS.
Sure.
In 2004, the standard was agreed, and it came out what we call the version 1.0, which is the de facto standard of what TEDS is. And the question is, you know, again, making sure the data acquisition manufacturer and the software and the firmware supports the particular sensor you're trying to communicate with. So it's pretty much, you know, as long as, let's say, you know, if you buy a piece of equipment from a certain data acquisition manufacturer, if that equipment is up to date in terms of software and hardware, you know, chances are very high, I mean, that you're going to have no issues.
Right.
But if
So
you have a node equipment,
if a vendor supports 1.0 and a user has version 0.9 TEDS, is there a migration path?
there is a migration path, yes. Sensors can be, the TEDS memory in the sensor can be reprogrammed or updated into version 1.0. And you can do that through your annual calibration maintenance of the sensor.
Sure.
Okay? But again, there's no reason to change anything if the sensor you have already talks to the equipment that you're using. If they work fine, they communicate with each other, that's fine.
Is there anything else versus TEDS, explaining TEDS options or templates that our community might be interested in?
There are a couple of options and templates, sure, and they are mostly depending, you know, what type of sensor you're using. So, like for example, an accelerometer is 9 out of 10 times what's called the template 25, and that applies to piezoelectric and ICP type accelerometers.
And what's the basics of template 25?
Template 25 will list a lot of different characteristics that are common to that type of sensors. For example, if you have an accelerometer, that accelerometer can be uniaxial or triaxial. So you're going to have a field that defines that. And you're going to have the sensitivity for each of those directions. There are other templates, for example, you could have like a bridge mode sensor. And that type of sensor would have some other parameters like the voltage power level, which is unique to that type of sensor. And so different types of sensors will have different types of templates depending on the technology that's being used and depending on what type of information is relevant to that type of technology.
Thanks. We should get near wrapping it up for our community today. One of the last questions, is there a lead application or example that's really turned out to be a prime benefit of using TEDS?
Sure, yeah. The obvious application is being multi-channel. You know, types of application where you have hundreds of channels. So in the vibration world, for example, motor testing. You know, ground vibration testing, aerospace is one of the biggest example where you have hundreds of channels and you're testing the airplane structure and for modes of vibration. And there are applications in the automotive industry, noise, NVH, noise vibration harshness, where you also, you also have vibration applications there, as well as multi-channel acoustic applications such as holography and noise mapping techniques and so on.
Okay. I think we'll wrap it up for today. If our community would like to find out more information on TEDS, where would you direct them to?
You can visit the Motorshop website at motorshop.com. We have a lot of information in there, including the frequently asked questions document. And there's also the IEEE website, where the IEEE standard for TEDS is the 1451.4. So you can go to the IEEE website and they have a tutorial there, they have several documents, and they have the standard that you can purchase and download from the IEEE website.
Okay, thanks for your time. Thank you for joining us today for a little bit of learning on the State of the Union on TEDS, and come back and join us again soon. Thanks, Marco.
You're welcome.